Hello, this is question 9 on your June 2019 paper 3 from AQA. You have this curve and we have to prove that the curve does not intersect the coordinate axis. So let's go into see what happens when we try to find the intersection with the axis. So the vertical axis, the y-axis, is x equals 0. If we substitute x equals 0 here, we have 0, 0 equals 12. 0 equal 12, which is not possible. Yeah, so the left hand side is different than the right hand side, you want to say that way. And when we try to do the intersection with the x-axis, so y equals 0, again we have 0, 0 equal 12. So we have the same problem. The left hand side is different than the right hand side. That's the first part. Then show that the derivative of y with respect to x is this expression here. To differentiate this function, as we have the x and the y quite mixed and it's not easy to make one of them the subject, we are going to use implicit differentiation. So and we have two functions here, so we are going to use the product rule for this bit and this bit. To use the product rule, I'm going to differentiate this one, multiply by this one. So 2x, I'm going to do 2x multiplied by the second one, then plus the first one multiplied by the derivative of the second one. When I use implicit differentiation, I'm going to differentiate y, so I have 2y, but then I'm going to multiply by the y by the x. Yeah, and then the second one I'm going to do the same. I derivate the first one, so 1 multiplied by the second one, plus I don't derivate the first one, but derivate the second one. So times 4y to the power of 3 dy by dx. And derivative of 12 is 0. And now what I'm going to do, well, I can simplify some y's because I have y everywhere. So I'm going to divide by y. Yeah, I'm going to divide by y because I will be able to simplify at the end. So I'm going to simplify already. 3 and 2. I'm going to factorize because I want to make dy by dx the subject. So I'm going to write dy by dx multiplying 2x squared here, 2x squared here, and then plus, here I have 4xy squared, 4xy squared. This is going to be equal to this bit, but it's going to be negative, so minus 2xy, and this one here minus y cubed, which means that dy by dx is going to be minus, I'm just going to write the minus at the front like they do, and then it's going to be this expression divided by this one, so 2x squared plus 4xy squared. And that's what we needed to find. Yeah, and I say I simplify here because you are going to have y's in the numerator and the denominator. I will be able to cancel them anyway. I just cancel them there because it's simpler. And that's all with this bit. Then prove that the curve has no stationary points. The stationary points are given by dy by dx equals 0. So what we have to do, even if you are not able to do this bit, you can use the expression. We are going to make this equal to 0 and see what happens. Yeah. So minus, this means that minus 2x, sorry, the minus is at the front of the everything. So 2xy plus y cubed divided by 2x squared plus 2x squared plus 4xy squared. This must be equal to 0 for finding the stationary point. So that means that 2xy plus y cubed must be 0, which means y times 2x plus y squared must be 0. So y must be 0, which is not possible because in the first part of the question they ask us the intersection with the x-axis. So this is not possible. Not possible because it doesn't cut the x-axis. Yeah, no intersection, no intersection. With x-axis. And then the other option would be that 2x plus y squared is equal to 0, which would mean that I'm going to do the way around. Y squared is minus 2x, and that's not possible because square root of minus 2x is not real. Yeah, so again, not possible. And that's it. So therefore, we don't have intersection with the x-axis because this cannot be 0. In the case when x is positive, find the equation of the tangent to the curve when y is 1. So we are going to find when y is 1 what is x to be able to write the equation. So when y is 1, if we go to our equation and we substitute y by 1, we have x squared plus x equals 12. X squared. That means that x squared plus x is going to be 12. That means that x squared plus x minus 12 is 0. When you factorize this one, you have x minus 3 and x plus 4 equal to 0. So x is 3 and x is minus 4. But they say x is a positive one, so we are ignoring this one and using just x equals 3. To find the equation of the tangent, we need the gradient and the point. We have the point, which is the 3, 1. We need the gradient. So to find the gradient, we are going to substitute in dy by dx the x by 3 and the y by 1. So what do we have the expression? We have the expression here. So I'm going to use this one. So I'm going to do 2 times the x times the y plus the y cubed divided by, all with a minus at the front, 2 times 3 squared plus 4 times 3 times 1 squared. Yeah? So this is equal to 6 plus 1, 7, with a minus at the front. You're not going to see with the line. Minus 7 divided by 2 times 9 plus 12. This is 1 square. It looks like 12, but this is 1 square. And this is 30, no? So this is the gradient, and I know the point. So I'm going to write y minus the y of the point, which is 1, is the gradient, minus 7 over 30, x minus the x of the point, which is 3. Yeah? And this is the equation of the line. I could expand the brackets. They don't ask me to write in any particular way, so you can leave it this way. I don't think it's going to look much better if we expand the brackets and multiply by 30. So I think this is enough to get the 4 marks. Yeah, and that's all with this question.